Metal cutting by hand often struggles with straight lines, and this device brings structure to the process. The first glance at its smooth guiding rail already feels impressive. The system begins with a sliding mechanism that locks onto a support track. The torch is placed in position, moving along the rail with controlled direction. Each pass looks steady and reliable. The guide allows both short and extended cuts, adapting to different plate sizes. Operators no longer depend only on freehand skill, but on the stable guidance of the rail. Watching the torch glide gives a sense of clarity. The heritage of Solingen blades resonates with centuries of craftsmanship, and the process inside the factory unfolds with remarkable continuity. The first action is split-cutting the raw material, shaping segments into manageable portions for the forge. Using alloys like chrome molybdenum vanadium and even Damascus steel, Felix knives unite long-standing tradition with contemporary strength. In the forge, each piece is struck into the outline of a knife blank, where its form becomes recognizable. The hammering stage fills the air with energy, marking the true beginning of the knife. The controlled force of every strike ensures uniform shaping, avoiding irregularities. Excess edges are removed in the deburring stage, cutting away flash material and defining the silhouette. It is fascinating how much shape emerges so early in the process. The blank is then perforated, introducing holes for later assembly. Hardening follows with heating in controlled furnaces, where structure and toughness begin to set. The glowing blank is plunged into oil for quenching, locking strength into the steel. Workers straighten each blank after cooling, ensuring it can progress further without stress defects. This correction step prevents flaws that could compromise future performance. Every movement here has to be precise, as even small deviations could affect durability. The blade surface is ground to level thickness, and drying removes residual moisture before additional steps. Attention turns to the bolster, where pre-grinding establishes dimensions. The blade undergoes fine grinding, called pleiston, giving the surface a smooth yet lightly textured finish. This stage reveals both discipline and artistry in equal measure. Cleaning prepares it for handle fitting, and handles are assembled, called reeden, mounting each handle to its tang. The next step is finishing of the handles by hand, called ausmachen, sanding and shaping them for balance in the grip. The feel of the handle is as important as the edge, ensuring comfort during use. During assembly, cleaning and in-process inspection maintain standards, checking alignment and surface condition. The cutting edge is sharpened on the grinding stone. This step is called abziehen, a traditional method preserved for reliability. Sharpening is performed with steady rhythm, creating an edge capable of demanding tasks. Cutting inspection confirms sharpness by controlled tests, ensuring consistency across batches. The moment of testing is decisive, proving the blade worthy of its mark. The final phases include packaging and end inspection. Every knife is examined under light before leaving the facility. It is striking how many human touches remain even in a mechanized environment. That balance of machine efficiency and hand finishing defines the spirit of Solingen. Steel wheels are the backbone of heavy-duty agriculture and construction equipment, and in Telford, UK, an advanced facility brings this production to life. The atmosphere inside is filled with the rhythm of machines shaping raw steel into dependable products. Walking along the production line, the scale of automation becomes truly striking. The process begins with rim production, where steel coils are cut and formed into widths ranging from 8 to 42 inches and diameters from 16 to 54 inches. Automated lines bend, roll, and weld the steel, producing strong single-piece rims. The heat and sparks at this stage create a vivid industrial scene. Next, discs are manufactured to match the rims. Using CNC machining, discs are cut, drilled, and shaped with precise geometry for mounting and load distribution. The clean, repeated movements of the machines are strangely satisfying. Once prepared, discs and rims move into welding cells, where automated systems fuse them into complete wheels. Both fixed and adjustable designs are created depending on the application. Seeing stacks of finished wheels lined up gives a sense of achievement. Corrosion resistance follows, beginning with an E-coat layer that shields every surface. A powder paint top coat adds durability and a uniform finish. The final color coating shines under the factory lights. This final touch not only protects but also emphasizes the quality of the work. Completed wheels undergo inspection before packaging. Global customers depend on their strength for tractors, trailers, and light construction vehicles. From raw steel to finished wheels, the sequence highlights technology and experience working together. Every step feels like a statement of reliability.
The trailer floor is built to take a beating long before it ever leaves the factory. In this scene, workers position and weld each floorboard onto the steel frame with speed and accuracy. The material type depends on what the trailer's built to carry, whether containers, machinery, or bulk cargo. Every weld counts, ensuring long-term durability under constant stress. Step inside the Nydalen tool factory to see how tradition meets technology in every Fiskars shovel. It all begins with a steel plate. Large sheets are fed into a stamping press, cutting out the blank that will become the spade. This piece is then sent down the line for forming. To give it strength and shape, the blank is heated and press-formed into its familiar curved profile. It's mesmerizing to see glowing hot steel molded into a tool that will dig for decades. Timing is everything here. Each piece must be heated to the exact temperature before forming, or the steel could crack or deform. The press hits with enormous force, shaping the blade in a single, fluid stroke. A quick inspection follows to catch any flaws before moving on. Each blade then undergoes a cleaning process to remove oxidation and surface residue, preparing it for coating. Only a clean surface ensures the red lacquer adheres properly and lasts through years of wear. Next comes surface treatment. The blade is sandblasted to remove scale and imperfections, then sprayed with that iconic red lacquer. Part identity, part corrosion protection. After curing, it's time for assembly. The shaft is fitted securely onto the blade, aligned with care for optimal strength and ergonomics. With that final click, the spade is ready. Fiskars may only employ 14 workers at this site today, but automation and efficiency allow them to outproduce the 100 men who worked here a century ago. That's the power of refined process. Watching it unfold is a tribute to both heritage and innovation.
At the heart of the foundry, glowing metal flows like fire harnessed into purposeful shapes. The atmosphere here is both intense and captivating, drawing focus to every step. The process begins with melting, where scrap metal and alloying elements are charged into the furnace. Temperatures rise above 1,500 degrees Celsius, ensuring the mixture becomes fully liquid. At this stage, sparks and glowing surfaces make the scale of energy unmistakable. Next comes treatment of the melt, removing unwanted impurities and adjusting the chemical balance. This stage is crucial, since purity defines the strength of the finished casting. Before pouring begins, mold making takes place. Sand molds are prepared using compacted sand around precise patterns, forming cavities that will later capture the molten steel. This step is vital, because the mold determines the exact geometry and surface quality of the final casting. Each mold is a negative sculpture, designed to hold fire and give it form. Workers check vents and channels to ensure gases can escape during pouring. Even the smallest imperfection in the mold could ruin an entire casting. The smell of sand mixed with binding agents creates its own atmosphere in the foundry. In this stage, teamwork and timing are everything, ensuring no mold is left unprepared. Pouring follows, with ladles transporting the glowing liquid across the foundry floor. The controlled stream flows into sand molds shaped to exact patterns. The moment of filling brings tension, as every cavity must be reached without trapping air. The brightness of the molten stream is almost blinding, commanding attention. As the molds cool, solidification takes place. The once fluid metal hardens into a stable structure, capturing every detail of the mold. The journey from furnace to finished casting underlines how fire, skill, and engineering combine in heavy industry. Even after centuries, the essence of casting remains a compelling balance of tradition and technology. Mounted firmly on the CNC machine, the rail becomes the focus of a demanding machining task. The rail is fixed securely, while the WFT-13R boring machine sets spindle speed for a stable cut. The tool advances steadily, removing material with consistent force. Each movement feels deliberate, giving confidence in the result. Once the section is complete, the rail shows a clean cut. The outcome highlights both machine power and technical control.
When rebar needs to be joined in the toughest environments, tight spaces, seismic zones, retrofits, there's no room for compromise. That's where the HRC500 series position coupler steps in. This isn't just a connector. It's a high-performance mechanical splice engineered for safety, speed, and structural resilience. In this video, we're looking at the number 18 extender coupler, designed for Type 2 seismic applications. What's incredible? It installs with just hand-tight assembly. No torque wrench required. The process begins with 2 rebar ends, precisely prepared and aligned. The extender coupler is then placed in between. With its internal tapered thread design and locking mechanism, it grips both bars securely, even in confined or pre-assembled cages. An indicator groove on the coupler body confirms when it's fully engaged. That simple visual check makes on-site inspection faster and more reliable. No need for special training. Just align, twist, and go. Even in vertical applications or congested rebar cages, it fits cleanly without rework. That saves both time and labor on fast-paced job sites. Once tightened, this splice doesn't just meet expectations, it surpasses them. The HRC500 system is rated at 175% of the yield strength, FY, delivering full plastic performance in tension and compression. It's tested to handle cyclic loading and exceeds major building code standards, including Caltrans and UBC seismic requirements for Type 2 splices. This coupler isn't just for new construction. It's ideal for retrofits, transitions, and emergency repairs. You can even connect mismatched bar sizes with the transition coupler. Watching it come together. No welding, no threading on site. It's a simple, elegant solution to a complex engineering problem.
At DMG MORI site in Poland, a remarkable installation takes shape where XXL machining reaches industrial scale. The sheer size of the equipment instantly draws attention. The layout includes 3 DMC 210U machines connected to an LPP 160 system, forming an automated line for continuous operation. Next to them, 3 DMC 340U machines are paired with rotary pellet systems RPS-4, enabling efficient changeovers. The synchronized flow of machines moving parts feels powerful. 2 DMU1000 SE portal machines complete the installation, each with twin tables designed for parallel loading, reducing downtime and boosting productivity. Every detail here reflects engineering built for endurance. With these systems combined, the factory represents one of the most advanced XXL machining facilities in the world. It is impressive how scale and technology merge so seamlessly.
Watch red-hot steel rods transform into perfect grinding balls. This skew rolling machine makes it look effortless. Pure power. There's nothing small about this repair. In this stage, technicians tackle the liner and piston installation on a massive industrial engine. It's heavy-duty, high-stakes work, and every step has to be flawless. Liners are carefully lowered into place, forming the foundation for each cylinder. The fit has to be perfect. Any gap or misalignment could lead to catastrophic failure under pressure. Before moving on, technicians often double-check the liner seating using precision gauges to confirm exact alignment. Then come the pistons. Before installation, each one is checked, cleaned, and prepped. But here's the critical part: the O-rings. These seals are tiny, but they're essential. If they're twisted, pinched, or improperly placed, the engine won't hold compression. Watching the team handle these components with precision and focus, it's a masterclass in large-scale mechanical repair. No shortcuts, no guesswork, just skill, experience, and respect for the machinery. Here's what happens when robotics meets red-hot casting in modern industry. At idle press and Gauss, advanced die casting and automation come together in a seamless flow. From high-pressure die casting machines to gravity and low-pressure systems, they handle every phase, forming light alloy parts for automotive and industrial use. Robotic arms load aluminum, molds close with immense force, and perfectly formed parts emerge in seconds. It's a fusion of heat, pressure, and robotics, pure manufacturing magic. With over 900 robots and decades of expertise, they're pushing casting technology into the future. It may look like just a farm tool, but behind every machete is a legacy. Here's how that legacy is forged. In Manizales, Colombia, the answer is forged in steel and shaped by generations of skill. At this factory, over 1 million machetes are produced every month. The process is rigorous. Steel, sourced from Great Britain and South Korea, is cut, marked, and laminated using a method learned from German engineers decades ago. Next, the blades are pressed and shaped to achieve consistent weight and form. Then comes heat treatment. Each piece is tempered, hardened, and normalized to withstand harsh field conditions. Every blade is then polished, sharpened, straightened, lacquered, and fitted with a handle. Quality control is constant. Each stage includes inspections to catch even the smallest defect. Finally, the machetes are packaged based on regional preferences, from bare blades to wooden or plastic-handled options. The attention to detail is stunning. The plant isn't just massive, it's efficient. Around 900 employees keep 4 production lines running: machetes, scissors, drill bits, and hand tools. But machetes remain the beating heart of this operation. Monks, Wichi, what's fascinating is the cultural sensitivity behind every product. With 850 machete models, the team tailors designs to the habits of farmers worldwide. Some want wooden handles, others wrap their own. In places like Papua New Guinea, Ghana, or New Caledonia, they ship specific styles that match decades of tradition. To stay ahead of cheaper Chinese products, they rely on quality and adaptability, not uniformity. Their strategy: don't tell farmers what to use. Ask what they need and build it their way. Only 17% of production stays in Colombia. The rest heads to over 45 countries across 5 continents, and they're still expanding, targeting new markets in Brazil, Indonesia, and throughout Oceania. The company's roots trace back to a German-Colombian partnership formed in response to post-war steel costs. Though now fully Colombian-owned, it retains a legacy of German precision. Each blade tells a story of history, geography, and the hand that forged it. Some models are custom-made down to the curve of the tip or the way it's gripped. There's something almost poetic about how one tool can connect so many cultures. My clan. Here, making a machete isn't just manufacturing, it's cultural engineering. With 5 axes and precision software, no angle is unreachable. With 5 axes and precision software, no angle is unreachable. Watch the Okuma MU8000VL bring a spiral mandrel distributor to life from blueprint to flawless metal masterpiece. First up, turn milling. The machine launches with a 66-flute indexable end mill, R6.6, programmed via module works, spinning at 507 minutes and cutting at 105 meters per minute with a feed rate of 0.7 millimeters/tooth. Depth of cut, AP, is 0.5 millimeters. That's serious material removal in one go. Can you feel the hum of efficiency? Next, 4-axis rotary milling begins. The Fresa NVD SO12 end mill, with 4 flutes, spins at 3,185 minutes, cutting at 120 meters per minute. Feed is a precise 0.06 millimeters/tooth, with radial depth, AE, 12 millimeters. Perfect balance of speed and accuracy. The distributor's outer geometry takes shape. Then comes 5-axis undercut roughing. Using the same Fresa cutter, Module Works plunges at up to 30 degrees, roughing internal features with AP 10 millimeters, AE 12 millimeters. Hard work, but robotic arms hold steady. Watching it cut away metal is strangely mesmerizing. Every transition from turn milling to undercutting is seamless, thanks to real-time NC control and rigid multi-axis synchronization. Root machining and finishing are handled by Fresa Sphero XRO12 2 flutes, spinning at 4,034 minutes. Feed rate 0.12 millimeters/tooth, AP 3 millimeters, AE 8 millimeters. This final pass sculpts every internal corner with surgical precision. No fuzzy edges, no rough bits, just clean, functional form. The MUV series isn't just about specs. Okuma's MEIK design philosophy redefines expectations, offering 5-axis accuracy rivaling top-end 3-axis machines, but with fluid motion and ease. Module Works integration ensures every toolpath is perfectly cam-ready. Seeing the machine shift from roughing to finishing, tool collisions averted, coolant flowing precisely, table indexing, it's industrial choreography at its finest. That moment when everything aligns and the distributor drops out, gleaming and exact, pure satisfaction. This isn't just CNC machining, it's advanced manufacturing artistry. The MU8000VL doesn't just cut metal, it orchestrates, sculpts, and elevates what a 5-axis center can really do. If precision had a symphony, this is the overture.
Industrial pipe bending often demands control and strength, and this machine reveals how steel can be shaped into perfect curves. The first sight of the bending arm already gives a sense of power. Pipes with 3.5 millimeters thickness and up to 115 millimeters outer diameter are placed into the system. A clamping unit secures them firmly, while the bending arm rotates around a fixed radius of 1,200 millimeters. Each turn feels remarkably steady, showing balance between force and structure. Once formed, the bent pipe is released, ready for structural or industrial use. Watching the tube emerge curved so evenly leaves a strong impression of engineering discipline.